Okay, welcome back to math class. Yesterday we did the first half of 10-1 talking about just like what are the pieces of a circle and how do they work together. Today we're going to talk a little bit more about circumference and what that means for our circles. But first, I want to address what happens when two circles intersect and what that can look like. There are three different things it can look like when I have two circles. Either they're going to intersect twice, they're going to intersect once, or they're going to intersect not at all. And those are our three options for a circle. Intersecting twice is going to look maybe kind of like if you've seen a Venn diagram before or something like that. It's just going to be one circle, another circle next to it, and they're going to have two intersection points. If it only intersects once, it's going to look like two circles that just barely touch at one place. Not at all, obviously, it's just going to be two circles that do not intersect. So these are three options with intersecting circles. Either they cross each other twice, they just touch each other once, or they don't touch each other at all. Something that we can know about circles when they intersect, let me fix this one. I don't know if that's better or worse. If I put my centers in these circles, and then I connect these, you'll notice what I have here. Okay, let me label these. A, point B, point C, and point D. Looking at circle A, this is our symbology for a circle. Circle A and circle D. You label them by their center points. If I'm looking at circle A, the radius of circle A is from point A to point C, right? Because that's from the center of the circle to its edge. So the radius of A equals AC, line AC. The radius of D is going to equal line BD because that's from the center to the edge of circle D. So the radius of D is going to equal BD. So far so good. What else I know just about these line segments is that line AB plus line BC is what's going to give me AC, right? AB plus BC gives me the whole line. Similarly, over here, BC, this middle section, plus CD, this little bit here, equals BD, this whole line. Hopefully you're tracking with me so far. What I'm going to do with this now is you're going to encounter some questions on your homework that are going to sound something like this. If the radius of A equals 10, so if its radius is 10, and A to B equals 3, AB equals 3, CD equals 4, it's going to give you this much information, and then it's going to ask you a question like, find the diameter. So I'm just going to take this information that's given to me, and I'm going to plug it into what I know so far, and we'll see where we need to go from there. So looking at this, radius of A is 10, so I'm going to plug that in as AC. Let's plug it into this equation since it's right here. AC is 10. It also gave me AB, which is 3. Okay, so I already have enough information to figure out what BC is by just subtracting 3 from both sides of this equation. So BC equals 7. So if this is 3 and the whole thing is 10, then BC is 7. Now if I know that CD is 4 and BC is 7, then I know that BD, I meant to say find the diameter of circle D. They don't have the same diameter. Right, so if I know what BC is and I know what CD is, then I can use that to find BD, which is the radius of circle D. So 7 plus 4 is 11. So the radius of circle D is going to be 11. Now what we learned yesterday is that our diameter equals 2 times the radius. So if I know that my radius is 11, then I just have to plug that number in here and get D equals 2 times 11 equals 22. And we're done with that problem. That's the diameter. Okay, so this is what happens when circles intersect. Hopefully that was clear. Now we'll jump straight into circumference. You guys may have heard of circumference before, / found the circumference of a circle before, but just in case you guys haven't, we're going to go over every step today. Okay, so the first thing you need to know about circumference is the definition of circumference. It's the distance around the outside of the circle. So basically, like if you unwound the circle and made it a line, what would that measurement be? The way that we find that is with this equation. The circumference equals pi times the diameter. Now because our diameter equals 2 times the radius, you can also write circumference like this. Circumference equals 2 times pi times the radius, because 2 times the radius is the same as your diameter. Now if you're wondering what pi is the ratio of circumference to diameter in a circle. Essentially C over D equals pi. It's also what we call an irrational number because it's a number that has a decimal place that never ends. It's approximately 3.14 if you round it off. But what I'll have you guys do is on your calculators, you should have a pi button that's going to have a symbol that looks like this. That's what you're going to insert into your equation when you multiply it out. Okay, so if I gave you this circle and I said to you, find me the circumference of this circle, and then I gave you the radius was 4. You would just take this equation and you would go C circumference equals 2 times pi times 4. Or C equals 8 pi. Let me grab my calculator. 8 times pi. We're going to round to the nearest hundredth because like I said, pi is an irrational number. The decimals just keep going on forever. But obviously I don't want you to turn in homework where you've written out a bazillion decimal places. So we're going to round to the nearest hundredth and get C is approximately 25.13. It's that simple to do circumference. Hopefully you've done it before. The last thing that I will say about this lesson, I have 2 more definitions to give you. with our circles, we can have shapes inside the circle and shapes on the outside of the circle that help us figure out information about the circle. So if I told you that something is inscribed in a circle, inscribed by a circle, what I'm telling you is that that shape has been drawn inside of a circle. So a shape, if I inscribe a triangle into this circle, I'm meaning I'm going to put it inside the circle with its vertices touching the circle. That is a triangle inscribed into a circle. If I say circumscribed, that means going around the outside. So with that shape I drew, technically I could say this triangle is inscribed into the circle, and the circle is circumscribed around the triangle. Circumscribed is outside, inscribed is inside. But you might also see a square circumscribed around a circle. That would look like this. It would be a square with a circle inside. Again, with intersecting points. Circumscribed, a square circumscribed around a circle means the square goes around the outside. A triangle inscribed into a circle means that it's on the inside. What's important is that the points connect. So if you were looking at this circle inside of a square, and I told you that the length of the sides of the square were all 8, what you would also know about this, because the circle intersects here, you would know that the diameter of this circle is also 8.